This EV Tech Talk is part 2 of a question and answer series that we started. This will be recorded, so anybody who did sign up, you'll get a notification as soon as this is done. We also will be putting this up on our YouTube channel. I implore again, if you haven't gone to our YouTube channel, you should like it and subscribe. We put lots of great stuff up there, including these Tech Talks. Today, we are joined, as usual, by our EV expert, Mr. Dave Giles. But filling in for Nathan Bakey is Tim Dwyer, who many of you probably already know, but here Tim's going to weigh in as well in the world of EVs, because it's not just exclusive to just the EV guys. All the combustion guys, they need to start learning their way around as well, and Tim's got lots of information to share. While this is a Q&A, we have a couple questions that we didn't get to the last time. We're going to go ahead and jump right into those. So Dave and Tim, go ahead and take it away with the first question.
Perfect. Well, thank you, everyone, for joining us. Today is our second session, as Jimmy mentioned there. We're going to be doing several questions. Tim and I will be sharing some of the answers for these questions, but we continuously get questions. So, like as Jimmy said, is that if you do have questions, definitely continue to send them in. If you have any comments and whatnot as well, any other topics you would like to see. So even outside of EVs as well.
I neglected to mention to put the questions in the Q&A portion.
Totally.
Not in the chat. Chat is disabled. So if you have a question,
okay,
drop it in Q&A and we will get to it. If not this session, we'll keep it and answer it at a future one.
Perfect. Sounds great. Okay, so let's get into the first one. One of the questions came in, does the OE give the temperature of the battery before it'll create thermal event? And lots of discussion around batteries these days, different types of batteries. But one of the things that we have to understand, first of all, is what is a battery in the sense of a basic fundamentals of its setup, and how is the battery temperatures measured and monitored, as well as how are the individual cells being monitored. Because obviously in packs like this, there's 48 of these modules, and within each module, there can be 8 of these cells. And the cells make up modules, modules make up packs. And of course, you're not going to have a temperature sensor on every single cell within that battery. So the manufacturer monitors the battery's temperature for thermal events. So in the sense of like the battery starts to get warm while charging, it turns on its thermal management system, whether it's through a chiller, coolant, refrigerant directly, trying to remove that heat, or if the battery's really cold, it will generate heat back into the battery to warm it up to give the best performance within that battery for charging and discharging while you're driving. But the question is about what about the battery cells? And unfortunately, my camera, I don't know what happened to it, but you should still be able to see the cell here. And I have a 2170 cell, and obviously we don't have a temperature probe to every one of these cells. So the cells themselves actually have their own protection. And the way they're designed is how they protect themselves. So within a 2170 cell, there's actually 2 plates inside it. One plate is at the top of the battery material inside the cell, and I'm going to make that point is that a 2170 cell is basically a standardized cell. We're talking about 21 millimeters across, 70 millimeters down, and it can be shared by Tesla, it can be shared by Rivian, it can be used in all sorts of different applications. But what's inside the battery is their secret sauce. So manufacturers have very protected preparatory information around the inside their chemical mix and so on. So they don't release a lot of information, but we do know that battery cells that reach in around the 55 degrees to 60 degrees Fahrenheit can, cause the batteries to go into a thermal event. So the battery cells themselves are actually protected. So inside the first plate, as the battery starts to get warm, it actually pushes up on a disc inside the cell, which will then, basically allow expansion to happen within that cell, and hoping that the thermal management system can actually cool that cell down. If it continues to get even worse, the top part of the cell is actually basically indented a bit, and what will happen is it will do this. It will pop out like that, which will disconnect the positive terminal on that cell from the battery, taking the battery out of that module. And then, of course, then from there, if it continues to get hot, then it will start gassing itself. So it'll start to relieve the pressure from that cell to basically protect that battery. So to answer the question, there isn't individual battery temperature monitoring, and the OEMs are very protective of what these temperatures are, because obviously with our different types of chemicals within our batteries, like our NCAs, which is a nickel, cobalt, aluminum battery, which is usually a high performance, moderate cycle times. We see them in a lot of the earlier Teslas, like the S's, the X's, and even in some of the earlier 3s. And then, of course, we have our newer style batteries, which is our LFP batteries, that don't use any cobalt, as you mentioned last session, but they're a lot more durable, and they don't have the same thermal properties as an NCA battery. So every battery will have its own distinctive difference within its thermal control system. So it's interesting whether it's a pouch cell, cylindrical cell, or prismatic cell. They all have their own ways of protecting themselves to be able to take themselves outside of it. And it's really cool if you ever can get a cell and you can discharge and you can take one apart safely. It's pretty interesting to see how they're constructed, as well as you can actually see some of these safety things. And in fact, if you take like a Milwaukee or a DeWalt battery, which are usually 1865 cells, you'll see at the very top of the cell, there will be a bunch of vents all the way around it. So, once again, the way they can control their own thermal events within inside that cell. Okay, so, and one last thing, conditions that do affect battery temperature is charging the battery, discharging the battery through driving, as well as I mentioned. But some of the other things that do affect the battery, for temperature is ambient temperatures too. So thermal management system is very important part of a high voltage battery. I always say, like, maintenance, you look at maintenance on EVs, and you might be talking to your students about what are the maintenance things on the EV beyond what the OEM recommends. Is one thing is making sure that the refrigeration system is working properly, making sure that the AC system is functioning, make sure the condenser is clean, make sure the radiator is clean, make sure the coolant is topped up. These are all very important parts of EV's thermal system to protect its battery. So, okay. The next question is, are hydrogen fuel cells the real future and not batteries? If so, should we really focus on that tech too? So I'm going to hand this over to Tim, and he can answer that question.
I find it interesting, two parts here. Hydrogen fuel cells are the real future. I don't know that we really know what the future is, to be honest with you. That's kind of the exciting part. Old school technology in my brain, I enjoy learning about this. So I learned a lot about fuel cells just recently. So do we teach on it? Well, let's talk about that. A hydrogen fuel cell really is an electric vehicle. In a lot of cases, they use standard battery packs that are just smaller and more than a conventional EV or a hybrid. Have to ask yourself, how does a hydrogen fuel cell vehicle work? And it basically, you can see on the picture on the left there, there's high pressure containers that are filled with high pressure hydrogen. And my head years ago was, it ran off that gas instead of gasoline, but technically it is going to produce a charge that runs an electric motor. You can see all the orange cables on there. It is an EV. And so how does that actually work? Well, the heart of the fuel cell vehicle is a fuel stack. And if you can kind of picture, a battery itself, or, a sandwich, you've got a cathode and an anode, and it's separated by a membrane, and they've got this high pressure gas is run over the anode, which is the negative part, the negative plate, and off of that it releases protons and protons and electrons into this, I guess, off of that plate. The protons are able to go through this proton exchange membrane and make it all the way to the cathode and basically make a circuit, but the electrons are blocked by that membrane, so they leave the anode in a different path, which the path is orange cable. And the orange cable goes and produces work somewhere on its way back to finding its way back to the cathode. So it's just another circuit. It can't make it through the membrane. It goes through wires. As electrons are traveling through wires, we just tap into it and make it work. So it drives an electric motor. So technically, hydrogen fuel cells are powering electric motors, so they are an EV type of a vehicle.
And I'd like to add something as well, Tim, too. It's really funny because I always get arguments, people online saying, I hate electric vehicles. I think they're garbage, they're trash, they're not, they're not part of the future, not a solution. Electric vehicles are slow, they don't work well. Then I go, then they go, well, hydrogen is the future. Hydrogen, I believe in hydrogen. And I put a picture of what we see on the left there. I go, what do you see in that picture? Orange cables. So good point you made there, Tim, about the electrification of it.
So the technology is fascinating. What's the purpose, say of EVs and this type of a technology is, sustainability. We're trying to reduce tailpipe emissions and things like that. What comes out the tailpipe, I guess, really is on the other side of the cathode. You're releasing water and carbon dioxide, and that's pretty much it. On this engine, on this style vehicle. How do you get hydrogen? I mean, that's the other question. I mean, technically, I think that we're basically moving the emissions from the car to a plant somewhere and producing hydrogen. You can't make, I don't think, enough hydrogen within a vehicle to power itself. So they have a plant somewhere that produces hydrogen, and that's basically, I'd say 98% of hydrogen is made from methane gas, which is a fossil fuel, and it's through the fancy word endothermic process of heating it up. So now you have to have something that produces heat, so you have another fossil fuel heating up the methane to produce, this hydrogen gas, which has to be compressed and then transported to some place where a car can fill up. So we've created, I don't say emissions, but we haven't necessarily gone totally clean, maybe so at the car, but not necessarily as a planet. So are we going to teach it? It's cool technology. I think it has to be taught. I think anybody that's in automotive should be interested in all types of transportation like this. I'm from the old school where when we went to fuel injection, I didn't want to look at it because that was too complicated. So you have to keep looking at things as they come down the pike here. Go to the next slide real quick. That's going
to be my next. I was going to ask you, what about combustion hydrogen?
Well, there are combustion engines too that use it. And throw a quick story. When I was teaching my students, some of my students actually produced hydrogen to induce into their trucks while they were driving. So it was a combustion engine. They had a water bucket basically, and that's pretty crude, but that they dropped a cathode and anode. They dropped almost like jumper cables into water, and it was electrolyte, so they had saline in it, so it was a heavy water, and it boiled off the hydrogen in this bucket, and they trapped it and fed it back through like an electronic throttle valve switch that put it back into the intake of the car, and they were getting like hellacious gas mileage out of these vehicles by doing that. Real crude, real primitive. And Dave was telling me that diesel engines are probably the equivalent of that in a refined fashion, meaning that they do benefit from hydrogen gas probably more than any other combustion engine, but then they kick out a ton of nitrous oxides, and that's a no-go thing too. So they're putting a lot of pollution out that has to be dealt with. And I'm not sure the end justifies the means. I think we should teach it, but I'm not sure if it's secure for perhaps why they're being designed.
And I think it's still important to understand that if you are in the heavy equipment, truck and transport, bus and coach, teaching it. It's interesting. If you look at these engines right away, you see the EGR coolers is hydrogen because, like Tim said, produces more NOx. It produces NOx gas. I've seen some reports saying 4 times the NOx gas, which would kind of make sense. So that means that we're not going to get rid of our after treatment systems, such as our SCR and our urea. So we'll still have a dosing system. We'll still have diffusers. We'll still have, the catalyst to deal with the oxides of nitrogen. So, the benefit would be is that CO2 is like nil, and so and so forth, and you don't have any particulate anymore. So, so those are advantages of hydrogen in these applications. But because of that, combustion hydrogen in passenger vehicles, probably not very likely, in my opinion. Probably we'll see more and more of it in the truck and transport world. So, hey, you have anything else to add, Tim?
Nope, I think you covered it.
Okay, great. So perfect. We move to the next one. So why can't they, hence Tesla, incorporate a solar panel to charge on the go? And I love this one. I think personally it would be kind of cool if you had a car, that had solar panels on it that could actually charge as you go, especially in some of the southern, states and so on, where you get a lot of sun and, so on. But once again, there just isn't enough energy density space. The efficiency just isn't there. The amount of wattage these panels would produce to over their cost to incorporate it into the battery system is just not feasible. We've seen other cars in the past where we've seen the Prius where they had the solar panel on the roof, but that was merely only to turn a fan on inside the car when temperatures reached a certain temperature. Tim mentioned, I think it was a Saab or something that did similar, and really just turns a fan on to keep the air circulating inside the vehicle, but that was its only purpose. And funny thing is, on that Prius, that was like a $4,000 Canadian option on the vehicle. So it comes down to energy density. It comes down to aerodynamics. It comes down to cost. It's, rather than spend the money on solar panels at a charging station to charge the batteries at a station to charge a car, it's more feasible than putting solar panels on a vehicle. There is a company down here in Nova Scotia, believe it. It's called Raleigh. Give a shout out to them a bit, but they were actually incorporating a special type of solar panel that would encompass the entire vehicle. All the body panels and that would actually be solar absorbing, energy generating panels on the vehicle. But once again, cost and density of energy, it's a concept they're playing with. But once again, it's maybe in the future, but right now, just it comes down to economics mostly.
And I think the elephant in the room too is if you on a good sunny day, it still doesn't, I guess, take care of business, and we don't get good sunny days all the time. So there's there's that to deal with too. So I just think I like the idea of it using a solar panel to run something 12 volt on a car, like a blower fan or something like that.
Yeah.
But you're right. I don't see how it could stay up with an electric motor.
Yeah, it just
I
doesn't.
think our teammate Mr. Krieger has joined us, and he has a question. So
Oh no.
I know.
I'm kidding. That's to you, Dave. Trust me.
I'm sure that was spoken with love. Not a question, but as most of us probably already know, many colleges and universities have demonstrated solar charging as a mere source of power for cars. University of Michigan has a prototype that they travel around the country with, but it looks like a spaceship. The whole thing is covered with solar panels. The tires are about an inch wide, and they've demonstrated that the concept does work.
Yeah.
But we're a long way, as Dave has said, from practicality of a real vehicle. But the idea has merit, and I think others will work on it.
Yeah, I agree. I think that Michigan car down at the university, that's actually a competition. I think it's a global competition between universities where they build cars to go maximum range, and And I know Dalhousie down here has a similar vehicle that they compete with other universities for, putting solar panels on the vehicle, tiny little electric motors, lightweight as they can get it. But the concept is growing. So, okay, so we're going to move on here. Oh, sorry.
I was going to say this next question has a lot of creativity to it. If asking in your experience, what techniques have you found better way to explain how alternating current functions? This is, I don't know. Like I said, it's up to probably the instructor more than anybody. But flip your slide there, Dave. Dave was using a swing set. The idea of a swing set. I kind of like it. In essence, the swing goes back and forth, which is like alternating current. I like the idea that you can get frequency and amplitude out of this by how hard you push and how fast. I like that most of I guess if you think about it, most of the work is being done when the swing's at the very bottom of the arc. I mean, that's where the momentum is the strongest. If you were to tap into that energy, you could produce something off of that. I don't know if that helps a student or not. I used to use a kind of a similar analogy of breathing. Like, when you breathe in and out, the air comes in, goes right back out. When you're pulling it in, I guess the maximum benefit of a breath is when you're totally inhaled and you've got a full set, your lung is full of oxygen. Most of, the benefit of that breath is happening right then you let it out and you draw another one back in. Depending on how fast you breathe is frequency and how deep you breathe is amplitude, and how much benefit you get from all of that. So, like I said, it's kind of fun to play with. I don't think there's one size that ever fits all students, and I tried everything because you got to reach everybody. So, do you have anything else, Dave? Or you were going to show you the?
Well, I think Tim's right. It's like I used to love using wheel speed sensors and crank sensors and different methods, and even though there's they're generating different amplitudes, different voltages, and so on, but where a student can actually do that and demonstrate it themselves, they're creating the energy, creating that waveform, if you want to, using a lab scope on the side there, or even using a light bulb to demonstrate, that the energy is being generated by them doing something. And I think that's the work part of it. Like on the swing says, Tim mentioned, the harder I push, the higher the amplitude, in both ways. And one of the things the instructor told me years ago or showed us is they take a light bulb and then you can actually see it flickering, showing the frequency. And over time, I picked up a unit that actually would change the frequency of the AC voltage on the light bulb, and we'd still have the 120 volts, but I could turn it down to 20 hertz, and you could actually see the light bulb flickering. So, so showing the alternating current going through that bulb. So, so demonstrating it, but it's also very important. We were talking before, it's like AC voltage is very important on anything that's moving within the vehicle. So in a lot of electric vehicles, our AC compressors are DC inverted to AC. Our drive units, same thing, AC, 120 degrees phasing. Once again, it's being converted from AC or from DC to AC, as well as regen going from AC back to DC. So explaining that the two different types of powering systems, AC and DC, are present on EVs is important to, for them to understand. DC is one flow, one way. AC is back and forth. So it's many different ways of demonstrating it. But as Tim mentioned, every instructor will have their own methodology and how they want to explain it. So. But yeah, it's a great question. Very important. It's the fundamentals of drive electric motors, especially with an electric vehicle technology.
And Mr. Krieger, of course, has his hand up because this is an area he is knowledgeable and passionate about. So, let's let him have a say here as well.
Sure.
Just wanted to mention that as we travel around the country training instructors, there are several that don't yet believe that oscilloscopes should be an essential part of their curriculum for a lot of reasons, time being a major one. But if you had something as simple as a Vantage 1 or a U-scope, very inexpensive, you put that signal, whether it's a AC variable reluctance sensor or anything that generates an AC signal, seeing that voltage go above and below zero for visual learners and students can see that much better than a graph or a chart or even the swing set. But when you have zero at a midpoint and the voltage goes up on the positive side and goes down on the negative side, alternating current, and then you blend that conversation into what a meter reads, which is RMS, and a whole other subject, but it's a great learning tool visually to see AC as opposed to a straight line DC, and the two bounce off each other for better understanding.
I remember back in school thinking or learning about this, thinking, what do we need to know this for?
Well, one thing I got to say is that I wrote an article one time is will the real AC voltage stand? And Dick made a really good point on RMS meters, which is a whole nother subject. But if you take an oscilloscope and put it in an outlet that's capable of it, you won't see 120 volts. So amplitude, and that's a whole nother subject. So, but anyways, that's a real good point. Thanks, Dick, for adding that. Okay, so question number 5 was the isolation loop, determining where they are in a crash scenario. So this is I'm going to give you guys some really cool information. That'll probably take us to the end of our seminar here, but one of the things that the isolation loop, they're talking about the basically the first responders loops, where they're located. Sometimes they can be daunting, they can be hidden. Tesla does a good job. They usually label where that has to be done. Most manufacturers will label what the cut point is and where it is. In the event of a collision, airbags are deployed, usually opening up the circuit, which disables the entire high voltage side of the system. The 12 volt will still work, but in the back side is getting that information. Where do we find that information? How do we get it? And this is an amazing tool for an instructor to have on hand with your own device, and even get the students to do. I'm going to put this slide up here. It's called the EV Rescue application. It's designed for first responders, but it's incredible because it's free, which is even better. But it has all the vehicles for the most part. It's not perfect. They just did an update on it. It's completely free, and it has all the vehicle first responders guides in it. They also have the vehicle, and just before I keep talking here, if you take your camera right now and put it on camera mode, if you're using an Apple or an Android, just go over top of those QR codes and it will take you directly to the download, and the download is free. And so what's really cool about it as an instruction tool, it tells you exactly where everything is, the voltages, the safety precautions, it has information on location of components. It has the cable cut areas, as I mentioned here. It has the jacking points of the vehicle, which is a great resource as well. And it's not just for cars. So if you're in the truck and transport, bus and coach, or even if you're part of the electrical trade, if you're doing electricians training and that, this app has the vehicle side. It has the truck side. It also has the EVEMS side, the electric vehicle energy management storage for charging stations. So like it has all these, and even I think they just added in that doc in this first responders EV rescue, is they also have the bikes and stuff. So like lots of information in this app. It's completely free. It's fantastic. And if you are doing a seminar and you've been asked to do a first responders clinic one night, show them this. It's like, it's great, and just have them go through it with you on the vehicle that you might have at your center there. And, essentially, basically it gives you that information right at your fingertips. So completely free. It's a great resource, and definitely will definitely help you understand
I
Access
think
that information.
we lost you there for a second. So.
Oh, okay. Sorry, I don't know why my computer did a little glitch there. So
It's a Nova Scotia thing.
Yeah, it is. It must be. It's sunny out. That's why. So when sun's out, everyone goes, oh, this can't be Nova Scotia. So anyways, hopefully that if you don't get it, if you don't have it, just email Jimmy. He will. I'll send him this. He can send you the QR code or even the link. I do have the website for this as well too. I don't know if it's on my slides here, but anyways, once again, a great resource. Okay, so I guess that's up with our time. We're at the end of our session.
Timed.
Pardon?
Perfectly timed. You timed it perfectly, guys.
Oh, did what time is it?
It is 1:30.
I was wondering. I'm looking for my phone to find the clock. But anyways, that's good. So next month we'll be sending out. So I don't know if you want to maybe mention, Jimmy, what's when our next session is and possibly what it's going to be on.
Yes, it is going. He caught me off guard. It is April 17th. That's right. It's April 17th. Will be the next one again at 1 p.m. This topic, we'll probably see a return of Mr. Dwyer. He's going to talk about ADOS, because what we want you guys to understand is like ADOS is so far beyond calibration. Like ADOS, it follows combustion, it follows EV, and it goes so far beyond calibration. We want you guys to understand how in-depth you can get with it. So Tim is kind of become a master at this subject and has some great ideas and tips, and we're gonna hopefully everybody tune in on April 17th for that.
Perfect. Yeah, sounds great.
And again, if you missed this or you want to play it for somebody else, this will be up on our Facebook page later today. It'll be up on YouTube as well, on our YouTube channel, which is excellent. Everyone go like and subscribe.
Perfect. Well, I guess that's it for this session. Wish we had more time, but anyways, respecting everyone's time, I guess we'll conclude our webinar, EV Talk number 2.
Thank you very much, everybody. And thanks, guys,
Thank you.